Okay, so looking at finding the angle between a line and a plane. So typically a line will intersect a plane at one point in three-dimensional space. There are a couple of exceptions to that. Please see a previous video. But in the general case, when they do intersect, then how do we find this angle theta, the angle between the line and the plane? Well, what we actually do is we don't consider directly the angle between the line and the plane. We actually first of all consider the angle between the line and the normal to the plane, because the normal to the plane is a vector that is very easy to come by, and we know the direction vector of the line. So what we have is let's just take an example. So 2x plus 3y minus 2z equals 8. That's the equation of a plane. And let's say the line L has equation R is equal to 4, 5, 2 plus lambda times 1, 0, 2. So we have an equation of a plane and an equation of the line. And what we're going to do is we're going to find the angle between the direction of the line, which is this vector here, and the normal to the plane, which is the coefficients of x, y, and z. So I'm going to refer to this vector as the vector d, which is the direction of the line. And I'm going to take the coefficients of x, y, and z in the equation of the plane and refer to that as n, which is the normal to the plane. I'm now going to use that formula, cos of phi, so cos of an angle between two vectors is equal to dot product of the vectors, so that's going to be d dot n, divided by modulus of n times the modulus of d. But of course this could give an obtuse angle, so it could give this angle here instead. If the dot product was negative, it would do that. So what I'm actually going to do is I'm just going to take the modulus of the top, so that it will guarantee giving me the acute angle between the direction of the line and the normal to the plane. Okay, so that will guarantee the acute angle. And then once I get phi, then I can just do theta is 90 minus phi, because we can guarantee phi is acute, and therefore theta is also acute. So let's do it in this particular case. So we're going to get cos of phi is equal to the dot product of these. So it's 4 times 1. No, sorry. 2 times 1. So I'm just going to write out the vectors. So the normal is 2, 3 minus 2 dot 1, 0, 2 divided by the modulus of 2, 3 minus 2 times the modulus of 1, 0, 2. And mod the top just in case it's negative. I don't actually care about where it intersects. I don't care about this vector here or this number here, because that just helps find where they intersect. I just care about the normal to the plane, which is this vector here, and the direction of the line, which is this vector here. So those are the only two parts of the question which I'm going to use in the maths. So dot product, 2 times 1 is 2, 3 times 0 is 0, and minus 2 times 2 is minus 4. So I do need to mod the top, because the top is negative otherwise. Mod of that vector is root 17, just a bit of Pythagoras, and that's root 5. So that allows me to find phi. So I'll do inverse cos of 2, which is 2 minus 4 is minus 2, mod it is 2, divided by root 17 times root 5, gives me 77.47. degrees. That's obviously phi, so that's the angle between the line and the normal. So therefore theta is 90 minus that. So therefore theta is 12.53 degrees. Okay, in general, theta is equal to 90 minus arc cos of the modulus of the direction of the line dotted with the normal of the plane divided by the modulus of the direction of the line times the modulus of the normal of the plane. That is a formula which you can learn and execute, or you can quickly see what's going on with the diagram in the exam. It doesn't matter.